Hello, I'd like to build some peace and power in understanding. As you develop an application, once it reaches a certain level of complexity, there is a serious decline in the velocity of developing the project. In other words, there's a certain critical mass, you can think of lines or code or whatever way that you want to break up, enumerate upon the accomplishments to that point. But there's a certain point in the development of software that unless you have put the thought in and exercised the practices that lend to a kind of chunking and providing a framework for organizing your thoughts around the next thing, you're going to fall victim to slow down, and really a lot of hindsight starts to kick in, and you realize all the technical debt that has accumulated. So today, really, what I want to share with you is around this notion of best practices, and kind of particularly partitioning the API portion. In other words, if you're designing, especially this is designed for people who are creating libraries, where you have some type of, the users of what you're creating essentially are going to be other programmers. So that's what this is centered around, I should say, up front. So if you are designing libraries, something else, or frameworks, something that, you know, another developer, plugin system, a plugin, something that other developers are going to end up using. You're going to be speaking with them, hopefully through a clearly defined application programming interface, a clear API. And there's different ways of organizing your API, but organization, however it's done, needs to be pretty much done in advance to optimize your production. So I want to share with you one approach that I am using, as I am ironing out a game engine that, again, some would say, kind of stretching the definition of the term game engine, but beyond that, it's a project where the end user is going to be a developer that's going to be using an API. So you want to be thinking, okay, beyond it being a developer, if I'm doing something that is fairly specific, which I'm creating a game engine, so the context of what that developer is going to be dealing with is already restrictive. It's already going to be within that domain of game development. If I was just making a general utility type of programming library, then the domain could be really, really wide, and you might not want to take this approach that I'm taking. But if you are taking a particular, if your users, your developer users are going to be working within a restrictive domain that has language associated with it, that conveys or connotes specific things within the context of that domain, then this could be very helpful for you. And it could be helpful for you even if you do have a broad, a very, very broad audience with not really a specific domain. It could also be helpful with you. So I ask you to bear with me here. So if you look in the project over here, I'm down in the source code in my game engine source code. And then in my modules, so I'm already organizing the code in a module system. Now this is JavaScript, so I'm using, just basically these ES module system, or the ECMAScript defined module system. Within the module system, I have certain things that they're modules, but they're also defining custom elements that would appear as custom HTML elements. I have others, just kind of like looking at some of the other things that are modules. I have a flags area where this is very specific. This is a module that has a top level that defines flags. And then I have this other section right here that's ECS. These are specifically modules that define entities, components, and systems. So that's part of the entity component system. That's another way of organizing your thought in terms of entities, components, and systems. I have things that are specifically utilities, that are broad-based utilities. And then I have some vendor code in there that are also modules. I want to focus, though, on this subdirectory right here, DSL, that's talking about domain-specific language. So if I go in here, you can see at the top level, I have this add module, which basically defines an add method that appears at the top level of my API. So my API is defined at the top level as this CS1 global object. And then right below that, we have these kind of top tier properties. Some of them are methods, other ones are objects that then have their own properties and so forth. But the word add that I'm using right here for this module, and then also for the actual function that's getting defined, is a very commonly used word, but could be used in a lot of specific subcontexts within the domain of creating a game. Within creating a game, I might want to add a 3D object to a game. Maybe I want to add a particle system to a game. Maybe I want to add, so there's different things I can add. I can add primitives that have been defined within the entity component system. So by having this language of add, which could be used reasonably in a bunch of different ways inside the domain or within the domain of game development, and then also even more specifically within game development using an entity component system, then I can take advantage of that. I can utilize that connotation of the word add, and I can also empower it to be used in different ways. Where the developer who's using this library, this game engine, can use cs1.add, and they can use it in multiple ways, and they can, in a very short period of time of getting on board with the engine, they can realize, hey, they can realize all the ways that they can use that method just by calling cs1.add and passing a variety of things in there. They can get the result that they want, and then it could save them a lot of coding, just making things more intuitive for them, and making a lot of things happen that are to their benefit. And we're going to kind of review some of those things. But before we go any further, again, we're using language that is naturally occurring within the domain. So it's domain-specific language. And then beyond that, we're using language that can kind of be invoked in these specific subcontexts. Like if I want to add a primitive, like a box, I would, I can use the CS1 add to add that primitive. Or if I wanted to add like a 3D model where I had the URL ready because I just made a 3D model and I put it at a CDN, and I have the URL string for that, and I can just use the add function in that way, and it will know kind of behind the scenes in the engine how to resolve that, whatever is returned, as being like this 3D model based upon the URL that was passed in. So let's take a look at how this is done. Essentially, I'm using something that's not purely done in JavaScript, but we can kind of fake it, and that's the concept of overloading. So if we think about the concept of overloading functions, it's basically taking a function name and being able to use that same function name in multiple ways. And that's still what you're going to see here. in a moment. So right here, I'm organizing this. I'm exporting here, so it's just using ES export, and I'm exporting this add function that ultimately gets appended to the CS1 global objects. It becomes CS1 add. Down here, you can see it's actually defined at the top level as this just standard anonymous function, but it returns a promise. So right off the bat, a common theme throughout my engine design is that I am attempting to kind of hide a lot of the complexity that deals with asynchronous things that happen in different orders or might never happen, might or might not happen behind the scenes, kind of handling a lot of that and taking that off the plate of the developer actually creating a game. And I'm also using promises in a fashion of kind of like conditional lazy loading. Like if you think about, if I don't need that, then I don't want to have to bring that dependency in. And that's another way that this is being used, is to asynchronously kind of reach out and bring in, it could be source code for something, it could be bringing in assets via CDN or source code. And then my system is also designed to be a progressive web application with a service worker caching, so that once this is done the first time, your clients who end up playing your game or whatever will just cache those things the first time, and then they won't even have to, wait but a millisecond or so for that for that promise to resolve, because it will resolve locally within the cache. So there's also that aspect of using the promises to kind of pull in a lot of things that aren't in the actual CS1 game engine code directly. So you can have a fairly small bundle for the engine, and then as you're using certain things, it can dynamically pull them in and cache them. That's another aspect of this. So all of that thought was done ahead of time. That's why also, as I go through the process, I reflect and I redirect. I really want to have the core foundation of this engine set up so that I'm getting solid with principles, that as I build out other systems and so forth, that I'm going to make sure that I exercise these principles as well and figure which ones might work better in certain situations. So if I look over here at the code a little further, the add function takes possibly no parameters, one parameter, or two parameters. So right there, if you're looking at this top level anonymous function right here, it basically, in this kind of function parameter signature, if you will, can take, since these two parameters have default values, you don't have to necessarily even pass anything in for them, and everything will go fine. You're not going to incur any errors. But you can call the add with one parameter, first of all, or you can call it with two parameters. Of course, if you call add with nothing, it's just not going to throw an error. It's not going to add something. So that's first of all. And then if you're calling it with one parameter, or that first parameter, just considering even if it's one or two, that first parameter can mean different things. And that's what we're going to look at, how we're going to kind of simulate this overloading concept in JavaScript. So this first parameter is first set to false. So I'm going to check down here inside of this promise function definition, this function that's down here that's getting wrapped in a promise. I am checking to see if it's a string, first of all. So if it's a string, I am going to first of all see if it's in one of the defined, if it's defining one of the, if it's the name basically of a defined primitive. If it's the name of a defined primitive, I'm going to add that primitive to the scene, and I'm going to resolve the promise accordingly. If it's in a template, Now, a template basically is a clone. It's a clone of a node in the scene graph, or a node in the entity component system. Now, why would I even use this concept of templates? Um, so if you imagine like a game where you could grab things, all the players, maybe had a multiplayer game, and the multiplayers can go around the world, and maybe there were different atoms in the world. They can get like hydrogen and oxygen atoms, and they can put them together to make like water, form H2O. And if they drag them together, maybe if they put the O and the H together, they get a hydroxyl ion, and it kind of snaps together. Maybe it does a little animation, and you get this like hydroxyl ion. Maybe you can have that intelligence built into the system. So they did that at runtime. So in your game, you could actually at that point, maybe if they drug this oxygen and a hydrogen together, it kind of snaps and forms this hydroxyl ion. You could have it create a template or register a template with the system, which will then you could use later on by CS1 add against that template. So basically it could check to see if that exists as a template, a named template, and then it could basically, so you can actually define these things dynamically within the world, as templates that you don't even think of ahead of time, that the game, people playing the game could basically come up with. And then you can make clones of those different things. So that's another way things can get added, and you can say whatever that thing is that they made, they have access of it, and they can make copies of it, and it's a really easy way to do that. Down here, another thing we could do is we could see if this is defined in my map, my library map of resources that are available asynchronously. Where if my library map, basically if I go down to my utilities and go into the lib map, at this point it's just a JSON object where the keys are these different strings. A lot of them are like names of primitives or the names of components. It could be used in other ways as well, but it's just the names of some resource like a primitive or a component, and then a URL of where to fetch that code from. Down the road, I might use this for other assets or fetching assets and so forth beyond code. And then I can extend this lib map, and then you can even register things in the lib map. And I didn't add that yet as a developer using the library. But this lib map becomes really powerful because then you can code against it, and it can asynchronously reach out for this code if and when you need it. So in the add over here, in this overloading section down here, the next thing it's going to check if it if it cascades through these first, if, else, if it gets down to this point with the lib map section, it sees, hey, is that string that was passed in, is that a key in the lib map? If it is, I'm going to load that remote script. Now down in the future, I might add some other logic in here where it might not be a script. It might be, I might look for the script first, and then if that fails, rather than down here saying failed to load a script, inside of this catch, I could then do another try to see if it wasn't, or I can do some logic on the parameter name to see if it ends in like, I don't know, maybe the name ends in MP3 or something like that, if it's like a sound file or something like that. I would probably use a different system for that, but I'm just saying I'm always thinking about ways to consolidate and be intuitive. But what happens if I, for example, wanted to load one of these things that's identified in this lib map? Well, it would asynchronously load that script. So in the utils, I have an asynchronous kind of load script over here, and it basically has a promise, and it loads the script. It kind of appends it to the head of the document, and whoever's using this library doesn't have to think about that. They don't even have to think that it is asynchronous. they should know that if they need to get whatever it resolves to and kind of immediately change it or something, they would need to know that this does return a promise. But and then down here, the next thing, if it will cascade down through this branching if else if. Down here, it checks to see if it's a valid URL. If you're passing in a valid URL, it's going to, for the first parameter, it's going to presume that you're trying to add a GLTF model, like a GLB, a link to a GLB model. And then it's going to go a little bit further to see if the second parameter is a string. If it's a string, it's going to presume that that's the position you wanted at. If it's not a string, it's going to say, okay, that's going to probably be an object. Now, I didn't go else if it's an object in here, and I can actually do that and do more overloading. But I want to show you that even though there's not too much code right here, and there is a cascade of all these conditions, you're thinking, how are they going to understand this? Well, the reason that the person using this library should be able to understand it well, and I've already tested this with a person this morning, and they gave me feedback that it's very understandable, is because it's domain-specific language, and it just makes sense. So let's go use this a little bit. Let's go over into this, and I have this open over here. So this is what's going to happen here? So let me just refresh this, actually. And so I can move this over a little bit, so I don't want to click on the jukebox. And let me clear this. And so what I'm going to do here is I'm going to use that CS1 add, that domain-specific language, and we're going to use it a few different ways. Let's start off. I already kind of put a couple of these things in there. Let's start off with, let's actually do a different one. CS1.add. I just thought it would be easier just to use the JavaScript console. So if I just did CS1 add like a box, which is a built-in primitive, right? It's a built-in primitive. It's already available. If I do that and hit enter, look at that. It puts the box right over there. Of course, the box is partly below the ground. So how could we deal with that? And what I can also do is add some further logic under if it is a built-in primitive, and if the second parameter, as we'll see, is a string, then I'll presume it would be for the position. Could do that, but I'm going to do it this way. I'm going to go over here and say, okay, the second parameter is going to be an object. I'm going to say, first of all, we'll just say color, and we'll just say blue, and then we'll call that maybe. And then we'll put a position on that too. We'll say position, and we'll say that position is going to be 0, 3, -4. All right, and then we'll just go ahead and add that. And if we go over here, we can see there's that blue box at the position 0, 3, -4. So that just added in there. So again, using the same function, using it now with the second parameter that's an object. Maybe I could use the second parameter and check if it's a string when I'm designing this, and presume that I'm going to think that it's a position. And I can do other overloads. You can have so much fun with overloading, and then you can allow people to consume this whatever makes sense to them, right? So let me go back here, and what if I didn't add a box, which is a built-in primitive, but I added something that was a primitive, but it wasn't built in, but I registered it with the, but maybe I had registered it with the lib map, the library map, like the, let's see, CS1 particles, CS1 particle system. So I have a default for that. It's CS1 particles. When we hit enter, look at that. And that wasn't even built into the library. It reached out to a CDN to get that code. It injected it into the page. Whenever that promise resolved and it was available in the page, then it ran the defaults for that particle system, which you can see is this kind of like little fireworky thing. And it's down a little low, and we could do the same type of thing. We can pass in an object for the second parameter that kind of customizes the kind of what we have there. And let's illustrate that for a second. Let's add another. So if we did CS1 particles, and then what if we did, whoops, hold it. I shouldn't use this string there. Use that. So say I said that the preset was, whoops, preset was fire. And then the position was -4, 3, -1, right? And then add that. Look what we got over there. Look what's going on. Look. Now we got fire going on right over there. A particle system. Again, now that when this particle system loaded up this time through, when it tried to access the particle system, since I had already asynchronously reached out, well, it's always going to be asynchronously done. But whenever I first tried to check to see if the particle system was available, if you recall back, in the code, I first of all checked to see if it's in the defined primitives. So the second time I called that, so if I go over here, the second time I called it right over here, it would have been in the defined primitives, because whenever this resolved, it had to reach out over the internet to a CDN and get the code and fire it up and inject it in the page. It gets registered with A-frame as a primitive. But in this call, it's already defined. It's already there. And moreover, even beyond that, the source code for this is already in the client cache. So if this client, this is already installable too. I'm not capturing this part of my screen, but if you were seeing the address bar, it says that I can install this as a PWA. So if I open this up again, the same as a progressive web application, if I open this up again as a end user, not only it would run, it could have the particles available offline, and it would never have to go over the internet because it would already be in the cache as well. All right, so I want you to see the benefits of this at different levels, right? So let me go to the next thing right here. Let's just maybe just do one more example. We'll just look at, well, I think I already have it in memory. So what if another part of the overloading is what if I passed in, this is a URL, what if I just made some type of, what if I'm a designer and I just want to get something into the game really, really quickly? So I'm thinking about teams of professionals that might actually be using this someday. That's why I'm so concerned about performance, because I want to make it not only work for my students. I'm a teacher. I also want to make it work for some industry professionals to use. So what if I'm a designer on a design team and I want to get myself into a little game prototype? I can just go CS1 add and then pass in a URL to this model that I exported from as a GLTF GLB file. And if I do that, let's go see what happens right there. Of course, it's going to be overlapping some of the other stuff. But if I do that, look at that. It just drew that model. And if I go change the view, it threw the model right there in the world, because that was part of that cascading logic right there. If the first parameter was a string and it got down that far, basically it would see if it was a valid URL, and if it was, then it would go forward and then do the loading of it as a GLTF model and set it up. Now, maybe I want to put another copy of that in a different spot, so I can go over here, comma, and what if I passed it in as a string rather than an object? Because I have done this for this one. And what if I did 0, or actually let's make this 7, 0, -1. All right. So if I pass that in, hit enter, look at that. Now I have another one of those. And it knew that that second parameter, when it was a string, it was just going to be the position. Because naturally, if you just want to test something out, or you just want the bare minimal use case for getting something, if you wanted it to be a model in the game, it's like getting it in and putting it in a certain position. If I wanted to further specify how I want it rotated, for example, now let's look at that use case. So a lot of these things, this is overloading, and there's different situations, but they make sense. And this is the kind of progressive learning that I would rather to be doing myself as a developer learning to use a library or game engine in this case. All right. So I'm going to go back over here, and rather than this being a string for the second one, I'm going to have it be an object with position inside of there. And here I will say 9, 0, -1 for the position. And I'm going to say set the rotation this time as well. And I will set this to 0, and let me just say 60, 0. And I'll hit enter. And look at that. Now we have another model that's now rotated around in a different spot. Because, a lot of times you might just be fine with the default rotation, but maybe not. The next thing you want to do, if you wanted to do that, still a really simple API, intuitive. So if you think about yourself, if you were a designer, you just wanted to start placing your things throughout the game. Maybe it's not like drag and drop and move it throughout the game. You could also do that and build on top of this really easily, kind of like a GUI kind of system. But just from standard code, text code interface, this becomes very, very doable, even for somebody that is just learning to code or might not have any experience whatsoever coding. So we have all of these items, this built-in primitives, these primitive and components that were defined remotely, that were brought in via CDN asynchronously. The first one had to get brought in from the CDN. The second one, even though you couldn't tell, it just all happens, just all magically happens. The second one was brought in, it would have been already registered at that point, so that would have actually followed a different control flow. And then we can add all of the parameters. We can define parameters like color and position on objects. We can set position. If we just wanted to set position on this, we can just pass in a string for the second one. We don't have to define a full object, which would be a little faster to type out. Yeah. So hopefully you see the benefit of not only using language that makes sense, language such as the word add, and then seeing the power of using this concept of overloading, using the same name of a function in different ways, and in fact in intuitive and powerful ways. And maybe you put a bunch, a whole bunch of ways, and it doesn't take a lot of code to define these as a library developer. Doesn't take a lot of code. It's not going to eat up a whole bunch of memory and bloat your library out, because it's just cascade of if else's and so forth. But your users can then easily learn how to use this overloaded function, this CS1 add. They can use it, and they can decide how they're going to use it, and they can or just learn all the different ways and just use it in those ways when they need to real quickly, boom, 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 do something. And even integrate a GUI in the world on top of this, right? So they can even, in the world, they can add like a little GUI that they can expose then to the people that play the game to add these things. And so they can extend it and pass that on, the same kind of simplicity, the simplicity and the power of this abstraction, they can pass that on to the actual players, right? So it makes it manageable, it makes it powerful for the ultimate end user of the game, makes it powerful for the developer user of the library, even for the designer of the library like myself and whoever wants to contribute. It's also powerful because it's another level of organizing the source code that's intuitive as I design the library. And it also frames questions that I can get feedback from people, from developers, from users, I can say, does it make sense to do cs1.add and then try this out yourself, and you use this and give me some feedback. So this is like your interface. The domain-specific language is going to be things that show up. These are things that are going to be showing up. Player, get speed, get the animation, set the avatar, set the speed of the player. Like different language that's going to make sense, that's going to show up in this engine. So if you think about this DSL, if you're thinking about organizing your library with a domain-specific language, if it's specific enough to really take advantage of that, then do it. Then you can think about the consumers of your library are really going to be working with these, this domain-specific language, like add, or under player over here, player get speed, or player set animation, player set avatar, player set speed. Or it could just be cs1.player, because this is actually, if I think about the top level as cs1 and then .player or .game, .scene. So if we look at that over here, you can start to see some of that. I'm still very early in development. If I go over here, cs1.cam, there's the camera. Then under the camera, I have other things. Some things are built in due to A-frame, other things that I've added. So, or cs1.game, right? And then the game, I can see other things. I can start the game. I can pause the game. So certain things are on pause or it's set to happen. I have it set up by default. If you pause the game, that particle system is going to still be going for certain reasonable defaults. And then you can check all different types of things in your code. You can see if it's already going. So cs1.scene. So the scene, the game, all these different things. cs1, my player. So the actual player, my player dot animations, if they have animations, my player avatar. So if you think about this, and you don't have to design your API like this, obviously. You can have top level, you can have an assortment of top level things. I just have a single top level object that's the entry point to the API. You can think about it, it's a tree. It's a tree structure. And the leaves on the tree could be ultimately like strings, or they can be numbers. They can have to be or they can be a function. Basically, those are the three things pretty much at this point that they are going to be either like, or they can be booleans as well. Yeah, so they can be primitive data types, or they can be objects, or they can be functions. So if you're looking at these things that I'm sharing with you today and thinking, hey, maybe the thing I'm working on, or maybe this makes sense to use domain-specific language, then I highly encourage you to maybe reach out and share what your situation is. I like to hear stories from other people. So I know this has been a long video, but I found that this is so powerful because in my source code, this is really where my end users are going to be interfacing. It's really with this domain-specific language. And as I'm adding more language here, I can talk to other developers. I can talk to people. Does this make sense? Does the way, if they're methods, the way I'm overloading these methods make sense, and so forth? And then I'll even reflect on it. I'll do blog posts about it. I'll even, in my system, I have a system level kind of a section where the projects, if I go over here in the system level, my documentation, I'll build in like promises. Here's my promises right here. So I'm clear that domain-specific language is a big part of what's going on here in the promises. And there's some other things that are happening just automatically that are part of the promises. But right over here, the domain-specific language. And I have to update. This is just part of it. And some of my documentation is a little bit behind. Probably the first person to ever have documentation lagging. But, and then, yeah, so I do that. I'm always, it gives me a very clear thing to reflect on from the perspective of who's going to consume this. So if I go to my little, on the It's not much of a blog. It's more just like a personal journal at this point. It's not really an outward-facing blog, but you can go to it, and I link to it. Eventually, I'll make it more of a true kind of user community blog, but right now it's more of a journal thing. So if I go over here at DSL and configuration, then I'm kind of reflecting on a little bit at this point. I'll go back and I'll edit this little article talking about the domain-specific language. And as I do this periodically, as a developer of a library, it helps me, second guess. I talk about sensibly naming things. I don't go into overloading here. I should talk about that in here as well. I should have a separate section in this article talking about overloading in the DSL, or maybe a separate article. But these are ways that, since I'm not doing stand-ups, since I'm at home here during the COVID-19 crisis, I'm not doing and I have enough video conferencing already on my plate, so I'm not going to try to engage people with kind of stand-ups talking about a project that they're not even involved in. So I just have to self-reflect, so I kind of journal in these little articles and add little documentation, if you will, even within the repository itself. But it helps me, so I thought that maybe it could help you as well as a developer. If you're, maybe you partition off part of your source code and say, okay, yeah, that's going to be my domain-specific language directory, and then I can export those as modules, and then I can put them wherever else in the source code, wherever it makes sense, if it's in the entity component system or whatever your system is. But I kind of separate out the domain-specific language because this is where a lot of my contract is residing, basically. The usability from other developers is going to be defined right in this section. So I'm getting very clear what that surface area is for other people using the library. They're not just diving down wondering, how does this work? It's very clear how you're expected to use this. So when it actually gets to the point where I have this really running as a well-oiled machine, it will be not only performing in a well-oiled manner, but it will be able to get consumed, and people can learn the use of the library in a short period of time. That's all I have to say today. Again, please reach out. If you made it this far in the video, you have a great attention span in this era of kind of short form videos. But I thought it was time to kind of put this out there, and have a beautiful day.